In this video, we are going to solve week 7 graded assignment. So this is our first question. The question says, in a population, 60% of the people are male and 40% are female. So we have a population among which 60% of people are female and 40%, this is male, and 40% are female. Now, if you pick a person, what is the probability of that person being a male? So the probability of person being a male, let's say we are denoting male by M, female by F. So the probability of a person being male is going to be 0.6 and the probability of a person being a female is going to be 0.4. Now we have some additional information given to us, that is 1.69% of all females are colorblind and 8.73% of all males are colorblind. Now let's say C denotes the person is a colorblind. Let's see denotes the person. Let's see denotes the person is a colorblind. Now what is given to us is 1.69% of all females. So among all the females, 1.69% of them are colorblind. So it is what is given? It is probability of a person being a colorblind given that that person is a female is 1.69%. So it is going to be 0.0169. Similarly, 8.73% of all males are colorblind. So it is nothing but probability of C given M is equal to 0.0873. What is being asked to us? It is what is the probability that the person randomly chosen from the population will be colorblind. So if we pick one person from the population, what is the probability of that person being a colorblind? So we have to find probability of a person being a colorblind, that is probability of C. So using the law of total probability, it will be probability of a person being a colorblind given that person is a female into probability of female plus probability of the person being colorblind given that person is a male into probability of male. So probability of C given F is 0.0169. So 0.0169 into probability of female is 0.4 plus probability of C given M is 0.0873 into probability of a person being male is 0.6. So if you solve it, you will get this is equal to 0.00676 and this is equal to 0.05238. So you will get the final answer will be 0.05914. But the question asks enter the answer up to 3 decimal accuracy. So our correct answer will be 0.059. So this is the answer. Second question. Contingency table 7.1.a summarizes 2 categorical variables, that is status of completion of a course and the 3 websites from which the courses has been taken by students. So we have 3 websites, website A, B and C, and we have given the status of completion of a course, whether the student have completed the course or not. So completed and not completed. Let's look at the question. What is the probability, this is our A part, what is the probability that a student chosen at random will be completing the course? So we have to find out the probability of student completing the course. So let's see how many students has taken the course. So from website A, total of 320 students has taken the course. From website B, total of 450 students has taken the course, and from website C, total of 500 students has taken the course. So total of 320 plus 450 plus 500 student has taken the course. So this is nothing but 5, 6, 7, 9. So 1270. Now we have to find out probability that a student chosen at random will be completing the course. So now let's see how many have completed the course. So from website A, 120 people has completed the course, from website B, 350, and from website C, 200. So total of 120 plus 350 plus 200 student has completed the course. That is 5, 6, 7, and this is 6. So 670. So let's find out. So what is the probability that student has completed the course? It is nothing but number of students who has completed the course divided by total number of students. Total number of students. So this is number of students who has completed the course is 670. So this is 670, and total number of students are 1270. So this is 1270. It is going to be 0.5275. Now you have to enter your answer up to 3 decimal accuracy. So you will write 0.527, or you can write 0.528. This is our answer. Second part of the question, that is B. We have to calculate probability of student completing the course given student has taken a course from website A. So we have to find out probability of completion of a course given that student has taken a course from website A. So since we know that we have this information that student has taken a course from website A, so we can restrict our sample space to website A. This is a restricted sample space, and from there we can see that number of students who has completed the course is 120, and total number of students who were enrolled in the course from website A is 320. So what we can write it here is probability of completion. So how many students has completed the course? Who has taken a course from website A, that is 120, and total number of students who were enrolled in the course was 320. So it will be cancelled out, and this is 3 divided by 8, which is nothing but 0.375. So this is your correct answer. So this is our third question. Suppose a dice is thrown thrice. What is the probability of getting the sum to be even given the number on the first dice is odd? So a dice has been thrown 3 times. So for each of the throw, our sample space is going to be, for first throw, sample space is 1, 2, 3. The outcomes are 1, 2, 3, 4, 5, 6. The same for second row, the same for third row. The outcomes are going to be 1, 2, 3, 4, 5, and 6. Now we have to find out the probability of getting the sum to be even. So if given the number on the first dice is odd, information that is given prior to us is that on the first row, the number that appears is odd. So let's say it is our first row, this is our second row, and this is our third row. So we know that the number on the first dice throw is odd, and now we have to find out the probability of getting the sum to be even. So the sum can be even only in 2 cases. The first is if on the second throw, the second row the number appears to be even, and on the third row the number appears to be odd. The second is if this is second, this is third, the number appears on the second row is odd and the number appears on the third row is even. So in this case, so if we consider this case, the probability of getting the sum to be even is equal to, so second row even is how many numbers are even? So this is 3 by 6 into third row odd. This is again 3 by 6, which is 1 by 2, 1 by 2. So this is 1 by 2 into 1 by 2, that is 1 by 4. This case, probability of getting the even number is again going to be 1 by 4, since probability of getting an odd number is 1 by 2 and the probability of getting an even number is again 1 by 2. So this is 1 by 4. So the probability of getting the sum to be even on 3 throw of a dice is going to be 1 by 4 plus 1 by 4, because both the cases are possible. Either this will happen or this will happen. So this is going to be 1 by 4 plus 1 by 4, that is 1 by 2. So 0.5. So this is our correct answer. Question number 4. From a well-shuffled deck of 52 cards, 2 cards have been drawn without replacement. So 2 cards have been drawn from a well-shuffled deck of 52 cards. So we have 52 cards initially, and from there 2 cards have been drawn. So first you have drawn 1 card, and it also says without replacement. So once you draw 1 card from a deck of 52 cards, so you will only have 51 cards remaining when you are going to draw the another card. This is what is meant by without replacement. Now we have to find out the probability that the second card drawn is a heart. So we will consider 2 cases here. So the first case can be when the first draw is a heart, and the second case will be when the first draw is not a heart. So when the first draw is a heart, you know that the first draw is a heart, so probability of getting the heart on the first draw is going to be 13 by 52, since there are a total of 32 heart, and the probability of getting the another heart, because we have to find the probability that the second card drawn is the heart, is going to be 12 by 51. Since this is without replacement, so total 51 cards will be left, and we have already removed 1 heart cards from in the first draw, so total of 12 heart cards is remaining. So this is going to be 13 into 12 divided by 52 times 51. Now this is first draw is not a heart. If we know that the first draw is not a heart, in that case probability of getting the second heart to the second, this is also probability of getting second heart is going to be, so we know that the first card is not a heart, so probability of getting the first card not a heart is going to be 39 by 52, and the probability of getting the second card to be heart is going to be 13 by 51, because we haven't removed any heart card from the first draw, so we have 13 cards left. So if you find out the probability that the second card is a heart, then you will add both these cases, because both the cases are possible. So this is 13 into 12 divided by 52 times 51 plus 39 times 30 divided by 52 times 51. So you take 13 by 52 into 51 to be common. So this is 12 plus 39. So this is nothing but 51. So this will be cancelled out from here to here. This is 13 by 50. This is 1 by 4. So this is going to be 0.25. So this is the answer. Question number 5. Let the random experiment be tossing an unbiased coin 2 times. So we are tossing 2 coins. So our outcomes will be HH, HT, TH and TT. The event A is the first toss results in a head. So the event A will be HH and HT. And the event P is second toss results in a tail. Second toss results in a tail. So this is going to be HT and TT. And event C is that on both tosses, event C is on both the tosses, coin landed on the same side. So this is going to be HH and TT. Now we have to choose the incorrect statements from these four options. So let's check. So first option is A, B and C are independent to each other. So how do we check the independence of three events? In order to check the independence of three events, we need to check four cases. That is, first is probability of A intersection B intersection C should be equal to probability of A into probability of B into probability of C, and A, B and C should be pairwise independent. That is, probability of A intersection B should be equal to probability of A into probability of B. Third is probability of B intersection C is probability of B into probability of C. And fourth will be probability of C intersection A should be probability of C into probability of A. Let's check all these four cases. So A intersection B intersection C. What is the set? The set is going to be HH, HH and HH. So this is HH. Now probability of A intersection B intersection C is going to be 1 by 4. What is probability of A? See, probability of A is going to be 2 by 4, that is 1 by 2. And probability of B is going to be again 2 by 4, that is 1 by 2. And probability of C is again 1 by 2. So this is probability of A into probability of B into probability of C is 1 by 2 into 1 by 2 into 1 by 2, that is nothing but 1 by 8. So as we can see that probability of A intersection B intersection C is not equal to probability of A into probability of B into probability of C. So this is incorrect. So A, B, C are not satisfying this condition. So we cannot say that they are independent to each other. Hence, this is an incorrect statement and hence this option will be correct. So since we have already seen here probability of A intersection B intersection C is not equal to probability of A intersection probability of A, probability of B, probability of C. So again this will be correct and C will be incorrect. Now let's check the D option. This says probability of A union B union C is A into B into C. So what is A union B union C? A union B union C. This is going to be HH, HT and TT. So the probability of A union B union C is going to be 3 by 4, which is of course not equal to 1 by 8. So again this is so what is given here is probability of A union B union C is not equal to A into B into C. So this is a correct statement. So this option will not be true. So our correct options are A and B.
Question number 6. Two dice of different colors have been rolled. Suppose the blue dice is biased. So we have two colors. Say one color is blue, which is biased, and the other color is red, that is fair. The red color die is fair. Now the dice which is biased, that is the blue color die, in that case the probability of getting a 1 and the probability of getting a 3 is given to be 1 by 4. Probability of getting a 2, 5 and 6 is given to be 1 by 10, and probability of getting a 4 is equal to 1 by 5. So this is the information that we have been given for bias die, that is blue color die. and the red die is fair, then in that case probability of 1 is equal to probability of 2 is equal to probability of 6 is going to be 1 by 6. Now we are defining the event A such that the sum of the outcomes of two dice is even. So this is our event A and event B. You can see that the sum of the outcomes of the dice are all even in this case, and some of the outcomes of all the some of the outcomes of all the outcomes in this case are odd. This is odd and this is even. Now we have to find out. Now the question is, choose the correct option, choose the correct statements from the following. So the first statement is, events A and B are mutually exclusive. So how do we check whether the two events are mutually exclusive or not? So we check whether A intersection B is equal to phi or not. So as we can see from event A and B that both the events are disjoint, that is A intersection B is equal to phi. So event A and B are mutually exclusive. So our correct option will be A. Second is, so since A is correct, our C is incorrect. Okay, option number B, event A and B are not independent. Now we have to check the independence of these two events. So what is the criteria for checking the independence of two events? We check whether probability of A intersection B is equal to probability of A into probability of B or not. So as we can see from here that if A intersection B is phi, so probability of A intersection B is going to be 0. Now we have to find out probability of A into probability of B. So as we can see that one of the dice is biased and the other is unbiased, so the probability will differ for each of the outcome of the die. So we need to consider the probability of, so the probability for say 1 1, let's write it here, probability of 1 1 will be equal to, say if one is biased and another is unbiased, so one say 1 by 6 and other is biased, so it is going to be 1 by 4, which is making it 1 by 24. Similarly, let's look for 1 and 3. So that will be 1 by 6 into again 1 by 4, because probability of A and probability of B is same. So again it is 1 by 24. So similarly, we can find out the probabilities for each of the outcomes in event A and event B, and we will see that the probability of A is going to be 1 by 2 and probability of B will turn out to be 1 by 2. So probability of A intersection B, which was 0, that is not equal to probability of A into probability of B, that is equal to 1 by 4. So the two events A and B are not independent. So this option is also correct. Option B is correct. Similarly, option D will be incorrect because we have already seen that the option A and B are not independent. Now the fifth option is, in general, any two mutually exclusive events with positive probability are independent. So as we have seen in this example that the events A and B were mutually exclusive and they were not independent. So this option will also be true. So our correct option is A, B and E.
Question number 7. An urn contains a total of 12 chocolates. So we have an urn where we have total of 12 chocolates, out of which 4 are milk and the remaining are dark. So we have 4 milk here and 8 dark. Suppose a sample of 5 chocolates is drawn from the urn 1 by 1. So we have taken a sample of 5. We have a sample. We have 5 chocolates here and we have drawn 4. We have drawn 5 chocolates 1 by 1 from this urn. Now we have to find the conditional probability that the first, third and fifth chocolates will be dark, given that exactly 4 chocolates out of the 5 in the sample are dark. It is known to us that 4 out of the 4 chocolates out of these 5 chocolates are dark. So let's consider an event, that is, let's say A denotes the event that the first, third and fifth chocolate that we will draw are going to be dark, and let B denote the event that 4 chocolates out of the 5 in the sample are dark. Now we have to find out the probability that first, third and fifth will be dark given B. So this is going to be probability that A intersection B divided by probability of B. So what will be A intersection B? A is the first, third and fifth will be dark. First, 1, 2, 3, 4, 5. First, third and fifth will be dark given that the sample has exactly 4 chocolates, which is dark. So there are 4 chocolates that you know are dark. So that the 4 chocolates can be either on this place or on this place. So we have 2 choices, 2 possibilities, that is dark, 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 milk, dark, or dark, milk, dark, dark, dark. So we have total of 2 choices for A intersection B. We have 2 choices. Now we have to find out the probability of B. It means 4 out of the 5 in the sample are dark. So you have to first choose 4 chocolates from the sample, and as you know that you have a total of 8 chocolates. You had the total of 8 chocolates in the and 4 milk. So the probability of being a dark chocolate is going to be 8 by 12 to the power 4, and milk chocolates will be 4 by 12 because we want only one milk chocolate. So this is 5C4, this is 2 by 3 to the power 4 and 1 by 3. What is probability of A intersection B? This is going to be, so you know that 4 chocolates in the sample are dark, so you have to choose 4. So the probability of 4 chocolates to be dark is going, if it is this place, is going to be 2 by 3 to the power 4 and 1 will be milk. So this is 1 by 3. If you consider both the cases, so we have to consider both the cases, so you need to multiply it by 2. Now your probability of A intersection B is going to be 2 times 2 by 3 to the power 4 into 1 by 3 divided by 5C4, 2 by 3 to the power 4 into 1 by 3. So this will get cancelled out, and this is 2 by 5C4, that is 5C1. So this is 2 by 5, that is 0.4. So this is a correct answer. We will see one more way to solve this question. So let's see it here. So as you know that 4 out of the 5 in the sample are dark, 4 chocolates. So let's say first, second, third, fourth, fifth, and you know that 4 are dark. So you can choose in 5C4 ways, that is nothing but 5C1 way, to keep 4 chocolates in the sample are dark. So you can have either dark, 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 dark milk, dark, dark, dark milk, dark, dark, dark milk, dark, dark, and this is dark milk, dark, 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 and milk, dark, 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 dark. So these are the 5 cases that is possible, and you have to find out that on the second and fifth position, and you have to find out the probability that on the first, third and fifth position your chocolate should be dark. So if you look at all these 5 cases, only in this case and in this case you have the dark chocolates on the first, third and fifth places. So out of total of 5 cases, you have only 2 cases where the chocolates are in dark in the first, third and fifth position. So the probability will be 2 by 5, that is 0.4. Question number 8. According to a study, 50% of men and 56.3% of women have attached left earlobes. So probability of men having attached left earlobes is going to be 0.5, and probability that a person will have an attached left earlobes if it is a female, if it is a woman, is 0.563. Now consider a family with 3 children where the probability of each being a male or a female is equally likely. So if there are 3 children in a family, and so the probability that a child will be a male or a female is going to be equal for both of them. So probability of that a child will be a boy or a girl is going to be half and half. If the elder child is a girl with attached left earlobes, find the probability that the other 2 children are boys with attached left earlobes. So if you know that the elder child is a girl, now you have to find out the probability that the other 2 children are boys. So if we see both the events, let's say if A is the event that elder child is a girl with attached left earlobes, and B be the event that the other 2 children are boys with attached left earlobes, we have to find the probability of P given A, that we know is probability of P intersection A divided by probability of A, but as we know both the events are independent, so it is nothing but probability of P into probability of A divided by probability of A. It will get cancelled out and it will be nothing but probability of B. So what is B? B is that the other 2 children are boys with attached left earlobes. So probability of B is the first child is a boy with attached left earlobes. So the second child will be a boy with the probability 1 by 2, and it will have an attached left earlobes with the probability 0.5. And the probability that the third child will be a male with the probability 1 by 2, and the boy will have an attached left earlobes with the probability of 0.5. So this is nothing but 1 by 4 into 1 by 4, that is 1 by 16, that is 0.0625. So this is a correct answer. Question number 9. Ashraf needs to pass in at least 2 out of 3 tests conducted by an institute to appear for the qualifier exam. So an institute is conducting 3 exams. An institute is conducting a qualifier exam for which he needs to pass 2 out of the 3 tests. The probability of him passing the first test is 1 by 4. It is given to us that he will pass in the first test. Probability that he passes in the first test is 1 by 4, and the succeeding test is 1 by 4 or 1 by 8, depending on whether he passes or not respectively in the previous test. So what is mean by that? So let's say if Ashraf has passed the first, for the first test Ashraf has 2 choices: either he will pass the test or he will not pass the test. So if he pass the test, he will pass with the probability 1 by 4. So and if he fails the test, he will fail with probability 3 by 4. Again, for the second test, either he can pass or fail. So if he passes in the first test, then he will pass in the second test with probability 1 by 4, and if he fails in the first test, so he will pass in the second test with the probability 1 by 8. again, the third case, he can either pass or fail. 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 So this is what is meant by the statement that he will pass in the succeeding test with the probability 1/4 or 1/8, depending on whether he passes or not in the respectively in the previous test. Now, what is the chance of his appearing in the qualifier exam? So, with what probability he is going to appear in the qualifier exam? And as we know that to appear in the qualifier exam, he needs to pass 2 out of 3 tests. So, let's see. So, he needs to pass 2 out of 3 tests. So, let's say E denotes the event where he passes in at least 2 tests. So this is going to be pass, pass, pass. This is first, pass, 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 fail, pass, pass, fail. This is pass, fail, pass, pass, fail, pass is third. This is not, we are not going to consider this. So this is fail, pass, pass, fail, pass, pass. This is fail, fail, fail. So this will not consider, sorry, fail, pass, fail. Again, fail, fail, pass, fail, fail, fail. So these are the only 4 outcomes where for which he will be eligible to appear in the qualifier exam. Now let's find probability of PPP, which means pass, pass, pass. That is nothing but 1/4 into 1/4 into 1/4. That is 1/64. Probability of PPF is going to be, this is PPF. This is 1/4 into 1/4 into 3/4. So that is 3/64. Similarly, probability of PFP is going to be 1/4 into 3/4 into 1/8. So this is 3/8 into 16. And probability of FPP is going to be 3/4 into 1/8 into 1/4. That is 3/8 into 16. So the probability of him appearing in the qualifier exam is going to be 1/64 plus 3/64 plus 3/16 into 8 plus 3/16 into 8. You can multiply it by 2. So this is 3 to the 6. Now this is 3. This is 6. So 2, 3. This is 4. So again, this is going to be 6 into 4 is 64. So this is again 3/64. So 3/64 plus 3/64 is 6/64 plus 1/64. That is 7/64, and it is nothing but 0.109375. You have to write your answer with 3 decimal places. So your correct answer is 0.109. Question number 10. A toy manufacturing company has categorized all the toys they make into 4 categories depending on the battery life of toys. So we have 4 different categories, 1, 2, 3 and 4. It is assumed that the toys belonging from category 1 will last for more than 50 hours with probability 0.4, while these are the corresponding probabilities for the toys belonging to categories 2, 3 and 4, and it is lasting for more than 50 hours. So for category 1 it is given to be 0.4, category 2 it is given to be 0.5, category 3 it is going to be 0.8, category 4 it is given to be 0.2. Now if you are assuming that 30% of the toys are in category 1, so in category 1 30% of toys are there. In category 2 20% of toys are there. 20% of toys are there. Category 3 10%, and category 4 40%. Category 4 40%. Sarah went to the toy manufacturing company and randomly picked one toy. if the toy did not last for more than 50 hours, what is the probability that she picked the toy from category 4? Now, as we know that the probability that a toy which is kept in category 1 will last for more than 50 hours, which probability is 0.4. So what is the probability that the toy which is in category 1 will not last for more than 50 hours? That is nothing but 1 minus 0.4. 1 minus 0.4, that is 0.6. Similarly, the probability that the toy kept in category 2 will not last for more than 50 hours is going to be 0.5. For category 3 it is 0.2, and for category 4 it is 0.8. This is 0.6. Now let's denote some events. We have to find out the probability that she picked the toy from category 4. Now let's denote some event. Let A be the event that the toy did not last for more than 50 hours. Let B1 denote the event that the toy is from category 1. Let B2 denotes the event that the toy is from category 2. B3 denotes the event that the toy is from category 3. And B4 denotes the event that the toy is from category 4. We have to find out that what is the probability that she picked the toy from category 4 if the toy did not last for more than 50 hours. So this is nothing but an application of Bayes' theorem. So we have to find out probability of P4 given A. So according to Bayes' theorem, this is going to be probability of A given B4 into probability of B4 divided by sum over probability of A given Bi into probability of Bi, where I is varying from 1 to 4. We have seen previously that if the toy is in category 1 and it is not lasting for more than 50 hours, it means that probability of A given B1, this is nothing but the toy is from category 1 and it is not lasting for more than 50 hours. This is 0.6. This is 0.6. Probability of A given B2, probability of A given B3, and probability of A given B4. So what is all that? A given B2 is 0.5, 0.2 and 0.8. 0.5, 0.2 and 0.8. Also probability of B1, probability of B2, probability of B3 and probability of B4 is given to us, and that is probability of B1 is 0.3, 0.2, 0.1 and 0.4. This is 0.3, 0.2, 0.1 and 0.4. Now let's solve this. This is going to be probability of A given B4. This is 0.8 into 0.4 divided by 0.8 into 0.4 plus A given B1 into B1. This is 0.6 into 0.3 plus A given B2 into B2, that is 0.5 into 0.2 plus probability A given B3 into B3, that is 0.2 into 0.1. So this is 0.32 divided by 0.32 plus this is 0.18 plus 0.1 plus 0.02. 10. So if you solve 0.32, this is 0.62 divided by 0.32, that is 0.516. So this is a correct answer.